Okay, today we are going to learn about simple inequalities. Okay, so we used to learn about equation, right? Equation symbolize equality. Now we are learning about inequality. We have learned how to represent numbers on a number line. Okay, and since the number 10 is to the right of number 5, 10 is more than 5. So we write 10 is greater than 5. The symbol, remember? While negative 10 is is to the to the left of the number negative 5, right? So negative 10 is less than negative 5. That's how you write the symbol. Yeah, plus. Okay. Yep. So if you look at the example, solve each of the following inequalities and illustrate the solutions in the number line. So 3x is less than 27, right? This one is less than. Now you can solve this means you need to find the x using the usual way. So this one is 3 times x, so you just move the 3 to the right side, become 27 over 3, which is 9. So 3 is less than 9. Okay. Now beware that when you move things in inequalities, when you move a negative number from one side to the other side, either it becomes division or multiplication. The sign changes. So if this was negative 3, when you move the negative 3 to here, for example, become 27 over negative 3, which is negative 9, the sign also changed. You flip the sign, so it will become x is greater than negative 9. Okay, just in multiplication and division. We are not talking about addition and subtraction. Okay, in addition and subtraction, whether or not it is a negative number that you move, it doesn't matter. The sign never change. So sign changing only happens in multiplication and division of a negative number, by a negative number, to be exact. So okay, now the way you draw it in the number lines like this. So because x is less than 9, you just draw some numbers here, several numbers that also include 9, and because less than, it means you draw the arrow to the left side, just like that. It doesn't matter where this one ends. You can end it at 6, at 5, or you want to extend it until 4 or 3, up to you. As long as you show that it starts from that number, which is 9, and the arrow go to the left, and then it's fine already. Now the next one is negative 2x is greater or equal 4. Now this sign here kind of a bit different, isn't it? This one is more than, or is greater than, right? This one is less than. Now what about this one, these two with additional line there? So it's apparently it's just a combination of, for this one it's combination of the is more than sign and the equal sign combined become this. So A is more than or equal to B, while this one is A is less than or equal to B. What does that mean? Now let us see here. Let's solve this first. So let's move the negative 2 to the right side, become 4 divided by negative 2, which is negative 2. And remember, here you see how the sign changed from here to here. What the textbook did is they times negative 1 to both. Yeah, it's okay. So do you have 2x first? Now multiplying negative numbers, the sign immediately change, flipped. Okay, become 2x, and then the 2 move here, become negative 2. you can do it this way. Okay, just again my way, usually I just move the -2 to the right side, become 4 over -2, and the sign change, so become x, and then sign change become less than or equal to 4 divided by -2, which is -2. This one, same thing, right? But I like it because it's faster than this one. This steps is too it's too slow. Okay, so x less than or equal -2. So again, you just draw several numbers here, and you write several numbers and starts from -2 to the left side because less than, right? Now, what's the difference here is, if you don't have equal, it's just less than. That means the circle here is hollow, it's not solid. Okay, you don't color it, while this circle here, you see, is solid, right? You color it, you shade it, because there's an equal sign also. So it's a combination of less than and equal. Then what does that mean is, here 9 is not included, so x is less than 9. Maybe just start from 8.9, 8.8, 8.7, 8.6. But this one, -2, is also included. That's why it's symbolized by a solid color. That means -2 is also involved in it, in the answer. Okay, right. So a problem involving inequalities. Okay, so it's like also the application in real world context. Yeah, directly. So a curry puff costs 90 cents. By setting up an inequality, find the maximum number of curry puffs that can be bought by $20. Okay, let's see how they form the equation. 90x is less than or equal than, it's less than or equal to, this is how you read it, right? It's less than or equal to 2000, which is that $20, but you change it into cents, because $1 is 100 cents, right? So 90x is less than, why is it less than? Because $200 is the money you have, right? That can be bought by this. That means this is already the maximum number, so you can either buy the curry puffs which cost less than $200, or at least equal. You cannot buy more curry puffs than the money you have. You cannot, right? You cannot afford it. That's why it's less than or equal to 2000. So x, it's less than or equal to 2000 over 90, which is 2 over 9. So the maximum number of curry puffs that can be bought is, with $20 is 22. Because that's it. Because you don't mind the fractions, you cannot buy like 2 over 9 pack of curry puffs, Okay, so you cannot afford to buy 23 curry puffs. You can only buy 22. That's the point. Okay, that's all for simple inequalities. Very short, very straightforward, just like that. Done. Easy. Okay, bye.